Yo, we are looking at sections 3.2 and 3.3. We are looking at parabolas, your all-time favorite. And what I would not want you to do is to go anywhere on the internet and possibly find a way that you could program your calculator to do the quadratic formula. What? Anyway, we're looking at the vertex formula here, and there are some major points here that we need to kind of look at. So A is this factor that is in front. If it is greater than 0 or simply positive, that means we're going to be opening up smiley face. And if it is negative or less than 0, it will be opening down frowny face. So we have x minus h squared. So this h value is going to be the x value of our vertex. Keep in mind, this needs to be x minus. So if it is plus, just like this one, we'll need to have the opposite. And then our k out here is going to be telling us what we're going up or down. It'll be our y value of our vertex coordinate. So in this example for our first one, that is going to be negative 16 for our h, and we're going up a positive 4. Done. And for our next problem, we're going to look at this particular one. As you can see, our a is in front. It is a positive 1. Therefore, we should be opening up. It is. And then we have a negative 3 and a negative 2 for our vertex. So everything's going to be centered around this vertex. We can see there's a domain for this. We can plug it at any point, so it's negative infinity to infinity. Here, what is the range? Our lowest y value is here. It is negative 2. As you can see, it is a bracket, and we don't have a highest y value, so it goes up to positive infinity. X is equal to whatever this value is here in our vertex. So that is negative 3. It splits the graph in half, making it symmetric. And then the largest open interval where the function is increasing. Since we're talking about increasing and decreasing, we're going to have nothing but parentheses here. It is a parenthesis party. So it begins at negative 3, and it goes on to positive infinity is where we are increasing. And then watch out here. You might say, oh, well, we're coming from positive infinity. Yeah, that's for our y's, not our x's. So our x's are coming from negative infinity, and we are decreasing until we get to negative 3, all parentheses there. Same type of problem going into number 3. We have a negative a value here, so we should have a frowny face. Indeed. Our vertex here is negative 3, 2. We could either just look at the graph or we can look at the function. Same domain here. Following the same process here, do we have a lowest y value? No, we don't. Do we have a highest y value? Yes, we do, at positive 2. Bracket. Same thing with our axis of symmetry, cutting it in half. That happens at the x value of negative 3. And then we are increasing from negative infinity. These are our x values up until negative 3. And then we begin to decrease at negative infinity to positive infinity. Remember, we're talking about x's. Don't look at this and go, well, it's going down to negative infinity. We're talking about x's. And voila, looking at number 4, everybody's favorite. We're using this information given to us, and we're going to be writing it in vertex form, but we need our answer to be in standard form. All right, so you see those highlighted in blue. And so here we can see that our vertex, our h is equal to 3. I have it written here in red. Our k is negative 4, written here in blue. Our x value is 6, written in black. And our y value is 239, written in green. So we just simply take those values and plug those in here. The only variable left is a. As you can see, my y value here, x value here, and make sure we do this here. It should be minus our h value and then our k value. Math happens, and we solve, and we find out that we get our a is equal to 4. We're halfway through, people. So we use that same equation, the vertex equation, except now we don't plug in our x and y values. We leave it as x, and we are solving for our y. We do, however, plug in our h and our k. I went ahead and did minus negative 3 and just put plus 3 here. You could do that too. I would advise it. So first step here is to square this x plus 3. That means we have to FOIL. That work is done here. And then we have to distribute that 4, as you can see here. I have to subtract this 4 here, as you can see here. And we are done. And the rest of these we are going to just be solving. So keep in mind that we are going to have plus or minus here, as we do have in our quadratic formula. Keep in mind also, just like last section, when we have a square root of a negative, we will have an I. And you will have to simplify some of these radicals. So 49 is the highest perfect square that goes into 245. I take the square root of that, I get 7. I goes right there. Don't forget your plus or minus. Here, same exact thing happening here. Don't forget your plus or minus. Here we have a negative here, so we should have an I in our answer. Make sure you simplify properly. Here, we could take the square roots here. Lots of ways to solve this one, but this is probably the easiest way. I can simplify this, as you can see here. This is where I get that. And then I just solve for k. Now, these next couple ones, we can use the quadratic formula as given here. And I would highly advise looking somewhere on the internet, looking at how to program your TI 84, 83, or 85. Or you can factor whatever floats your boat there. If I can factor it easily, then I'm just going to do that because that's the easiest way to do it. And if I can't seem to do it, then I'd use a quadratic formula. If I'm too lazy to do either one of those, then you should program your calculator. And if you're too lazy to do that, well, that's your own problem. Here, I can factor, boom, 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 boom. I set each of my factors equal to 0 and solve, bada boom, bada bing. Here, I made sure that I multiplied by x, and I brought my 12 over, as you can see here. I'll label what is my A, it is 5, my B, -7, and my C is -12, and I went to my hunky-dory quadratic formula. Math happens, and I reduce it properly. So I have everything simplified to 12 over 5 and -1. Number 13, more of the same. I label what my A is, my B is, and my C. Put it into the quadratic formula. Simplify. Voila. I have two solutions of 1/5 and 3. On to 14, more of the same. The only thing different here is that we don't get a perfect square under our square root, so we need to reduce it. So as you can see, that is over here, 4 times 10. Perfect square is 4. Yes, I understand that 2 and 5 go into 10, but they're not perfect squares, so it's not even a consideration, people. And then there we are. And here we are. Make sure we get everything on one side. It has to equal 0. Here's my A, B, and my C. It's the first time that we have to deal with the square root of a negative number. Just pop that I on the outside. I can't reduce the square root of 15, and we're done. And make sure we get everything on the same side. My A, B, and C values. Plug it in. And as you can see, I can't reduce that 177, so there we are. Here we got a very special situation here. When we factor that, we have a perfect square. 81s squared is 9s. And we have a perfect square here of 4, and the square root of that is 2. Bing bong. So I just have to set one of those equal to 0, and I get s is equal to -2/9. We can see that we have multiplicity happening here, but we don't need to put that in more than once. One will do it. Here we're talking about the discriminant, which is just talking about what is under the square root value in our quadratic formula, so the b squared minus 4ac. There are 3 situations that can happen. We can either get whatever that value is equal to 0, which is the case here in this particular problem, which means that we have one solution. So our parabola is going to be touching the x-axis once. If we get a positive value here, so this greater than 0, so that means that we're going to have 2 solutions, meaning the parabola is going to go through the x-axis twice. And then our last is where we're going to have a negative number or imaginary numbers, because we can't take the square root of a negative number, which means we'll have no solutions. All right. Or we could possibly have no real solutions, however they name it over here, which means the parabola is not going to intersect with the x-axis. So that's how that looks. We have a visualization of that. So here we're using the discriminant again. Math happens. I get -23. And just like this states, if a negative number, I have 0 real solutions. Here we're looking at that same thing here. Here is my A. It is positive, meaning I should have a happy face, so either B or D. Then it says that my discriminant is less than 0, meaning I have 0 solutions, meaning it does not touch the x-axis like that. Get out of there, B. Oh, that's what I want. And then we have 21. My A is positive. I should have a happy face like B and D. My discriminant is also negative, so it should not touch the x-axis. There we go. And here, referring to the graph, we're looking to the right here as where we want the function is greater than 0. So this is simply saying, where is the function above the x-axis? I put it there in a beautiful looking highlight in green. Fantastic. So this is happening from -infinity to +5. It dips down underneath, and then back at 7 to infinity, we are ready to rock.